Hi, my name is Jaime. I am 13 years old, and this is my entry for the Bryson science competition of 2012. I live in Marbella, Spain, and I go to international school, Aloha College. Now, when I tell you the word sports, how would you relate it to it? Maybe the biology about it, as in the muscles or how you run, or even the physics about it, as in the speed, distance, force, anything. But there is actually a lot of chemistry involved in it, and that's why I'm here today, to give you 5 incredible reasons that will explain to you why there's a lot of chemistry involved in sports.
Hi, this is another reason why chemistry is very involved in sports. And basically, when you're settled down or doing much, the pH of your blood is usually around 7.4, 7. But after you do exercise and you move around, the pH decreases as your blood becomes more acidic because the carbon dioxide in your blood increases. So basically, I'm going to show you today how all of this works and why. For example, now I've been moving around a little bit, not doing much. So I'm just going to get my blood and measure the pH. And as you can see, I've been moving around, so I'm not settled down. It's 6.34, a bit down as I've been doing quite many things. But the usual will be around 7. And now I'm off to do some exercise. See you in a minute. I'm back. I've been doing some exercise. Now it's time to measure the pH of my blood after some exercise because of the increasement of carbon dioxide. As you can see, it's 5.66 approximately, as it has decreased because there's more carbon dioxide in your blood and your blood has become more acidic. Now this is the reason why chemistry is really involved in sports. Here in Spain, lots of people have pools, especially because they like swimming in the summer. Kids enjoy them, but pools need a lot of cleaning. And to clean the pools, people use disinfecting agents. Now, the most common disinfecting agent is people nowadays call chlorine, but it actually isn't the pure chlorine element because chlorine is a very toxic gas, which will probably kill you if you actually swam in a pool with chlorine. So what we use is a chemical compound such as calcium hypochlorite as a form of a solid, or sodium hypochlorite as form as a liquid. Now, what they do is they have chlorine particles inside them which spread inside the water when it's in the actual water, and then molecules spread and clean the water. Now, hypochlorous acid kills the bacteria and the other pathogens and by attacking the cell walls and like this, destroying all the bad stuff. Chlorine is typically prepared in liquid, powder or tablet form, and basically this is why people think that chlorine is the actual thing that cleans the pool, when it's not, it's the compound. Thank you. This is another reason why chemistry is involved in sports.
Yes, I'm sure you've all seen one of these before, right? Yes, I'm talking about energy drinks. Them drinks you see advertised on the TV, and you see sports people drinking quite oftenly. Now, these drinks can have advantages and disadvantages. The advantages are that they give you a limited amount of high energy. When you drink an energy drink, your body releases adrenaline more oftenly than you usually do, and this helps to give you more energy during your sports activity. But they also have disadvantages. They contain large amounts of caffeine as well as taurine. This combination of stimulants is a bomb for the human body. People have collapsed and died from drinking too much of this energy too quickly or even too oftenly. Now, I'm not saying here that these are bad. I'm just saying these are completely fine. They're actually good for doing sports. Therefore, they should be taken with precaution, should be taken not oftenly and not too quickly. And that's why this is the reason why chemistry is really involved in sports. Lately, people are getting really concerned about the end of fossil fuels. Yes, soon fossil fuels like coal, natural gas or oil are going to end. We're really concerned because oil is the fuel we use for cars to work. It's the most common and the easiest to extract. Now, even if we made a car that worked only with electricity or even nitrogen, we would still be wasting a load of oil. Now, you're probably thinking why, if we're using electricity, but all of the parts of the car, like this, the plastic of it, the seat, parts of the engine, most of the car is made using oil and burning coal. We've never thought about this, haven't we? But we actually are burning and wasting a lot of oil in this. Now, a way to prevent this is by using biodegradable plastic in cars, which wouldn't use as much oil and would last for much longer. But it's still quite concerned between some scientists, and they're still trying to look for the perfect way to not waste oil, although eventually it will run out. Yes, I'm sure you've all tried skating at least once in your lifetimes. It's a very common sport between the youngsters nowadays. I want to talk to you about skateboarding because of the wheels. Yes, these wheels. They are made out of polyurethane, a versatile and durable synthetic material invented by Frank Lasworthy in 1970. With their rubber-like grip on the pavements, polyurethane wheels expanded the potential of ways that skateboarders could use their skateboards. Different types of polyurethane skateboard wheels vary, mainly in terms of their geometry. Geometry is a measurement of how hard a material is. Diameter, color, and shape. All of these factors change the geometry of a material. The geometry is a measure of how hard a wheel is. Soft wheels best for crushing the hard surfaces and have a low geometry, such as about 87 A. A is the measurement of geometry, measured in A's. Hard wheels, which absorb little shock, have a high geometry, approximately 100 A. So basically, there's a lot of chemistry involved in the wheels because it all depends on the hardness of them, how hard you made, and that's why I learned you today what geometry means. Thank you. I hope this presentation has helped you to understand why there's a lot of chemistry involved in sports and why we can never judge something without investigating about it before, like I just did. Before this, I couldn't think that there was chemistry involved in sports, but after doing my research and some experiments, I realized that that was a complete lie. I thoroughly enjoyed making this presentation, and I hope you have enjoyed it as well. Now, I want to thank two people in particular that have made all my presentation possible and that you're watching it right now. My science teacher, Mr. Rob Davies, and the head of science department in the local college, Miss Elaine McGurl. I thank them for their support and their organisation and making everything possible. Thanks. Thanks for watching my presentation.